Alright, so welcome to the video for lesson number 5. So in class we had some time to try these on your own questions, but we didn't have an opportunity to go over them. So here's your opportunity to check your answers and see how you kind of did here. So let's look at A. So A gives us 5 cube root of y to the 8th power. Y to the 8th power is not a perfect cube. So when I try and separate that out, I want to find an exponent that's smaller than 8 that can be divided by 3. So y to the 6th works. Y to 6 times y to 2 makes back y to 8, so I haven't actually changed anything, just the way it looks. Then I know that y to 6 is a perfect cube, so this answer becomes 5 y to the 2nd. That's what happens when you take the cube root of y to the 6th. Cube root of y squared. Let's take a look at B. B is essentially the same kind of question, but now I have to deal with this pesky number inside too. So I have 3 as a root, 54. Well, if I look at my perfect cubes, I have 1, 8, 27. That's good because 27 times 2, that makes 54. X to the 6th is a perfect square, so that stays. Y to the 5th is not, so we have to figure out a cube that's perfect that's smaller than 5, so that would be y to the 3rd and y squared. Then we're going to take the cube root of anything that is a perfect cube. Cube root of 27 is 3. Cube root of x to the 6 is x squared. The cube root of y to the 3rd is just y. And then we have the cube root of 2 left and y squared left. Number 3 is a little bit interesting because we have kind of like 2 different things going on here. It's square roots, so we have to deal with that. And I'm going to kind of look at the top separate from the bottom. So the denominator, I can make b squared and b. The numerator, 48, the perfect square that goes into 48 is 16, goes in 3 times. A to the 6th and a. Separate the square roots, so the square root of 16 is 4. Square root of a to the 6th is a to the 3rd. I'm left with a square root of 3a. In the denominator, I have b, square root of b. And that's it. It's almost like I have 2 separate problems I'm doing at the same time. Part D is a cube root of a negative value. That's possible. So I can make a negative 8. Well, that's a perfect cube. M to the 4th, I can make m cubed times m. And n to the 8th, I can make n to the 6th times n squared. The cube root of negative 8 is negative 2. Cube root of m cubed is m. Cube root of n to the 6th is n squared. So I'm left with the cube root of m n squared. Let's take a look at E. So cube root 81, I can break that down to 27 and 3. A to the 5th, I can make a cubed times a squared. B to the 11th, I can make b to the 9th and b squared because 9 is going to be a perfect cube. Cube root of 27 is 3. Cube root of a to the 3rd is a. Cube root of b to the 9th is b to the 3rd. And then we have the cube root of 3 left, a squared, and b squared. That's about as hard as I would think that you'd see on a test or a quiz for this class. Part F is a 4th root, so we have to look at our perfect fourth. So 2 times itself 4 times is 16, and hey, look at that, it's a perfect fourth. So when I look at the fourths, well, 16 stays because I don't have to separate that out. X to the 5th, I can make x to the 4th times x. Y to the 4th, I don't have to change. It's already a perfect fourth. Z to the 10th, I can make z to the 8th times z to the 2nd. Then I could go through and simplify. The 4th root of 16 is 2. So then if we go through and look at x to the 4th, that just becomes x. Y to the 4th just becomes y. Z to the 8th becomes z squared. And then we're left with the 4th root of x, z to the 2nd. hopefully you're all good with those, and then you could try your homework questions. So for the homework questions, we had to first start by simplifying 125. Well, that breaks down to 25 and 5, which becomes 5 square root of 5. B was a little bit weird because it was a fraction and a part of it was a radical, some of it's added. But really, we're just trying to simplify this. Everything else is algebra 1 if you think about it. So 24, that breaks down to 4 and 6, which becomes 2 square root of 6. So this fraction is negative 4 plus 2 square root of 6 all over 2. Common mistake here is negative 4 and 2 square root of 6 are not like terms. You learned about that in geometry last year. And you also learned in geometry that you can simplify this by saying if all three of these numbers can be reduced by the same value, the whole fraction can be reduced. So then that becomes negative 2 plus the square root of 6, or 1 square root of 6. 128, well, I can make that 64 and 2. Square root of 64 is 8, so I have 8 square roots of 2 over 4. So this final answer becomes 2 square roots of 2. Number 2 is a really interesting question. Square root of 32 is 16 and 2, which becomes 4 square root of 2. The cube root of 32, well, if you think of cube roots, I have 1, 8, 27, so 8's got to be the one that goes in there. So it'd be 8 and 4. So that becomes 2 cubed root of 4. Fourth root of 32, well, fourth roots are going to be 1, 16. 16 goes into 32. So I have 16 and 2. Fourth root of 16 is 2, so I have 2 fourth root of 2. And the fifth root of 32, well, that's a perfect fifth, so that becomes just 2. So we can see they're all the same number, but because of the different index, we're getting a completely different answer. So the changing of the index makes a huge difference here. For number 3, if I break this down, so I have 36, x to the 4th and x, y squared, and z. Z can't be broken down, it's too small. It's smaller than the index of 2. 36 becomes 6, x to the 4th becomes x squared, and the square root of y squared is just y. Then I'm left with the square root of x and z. For the next one, if we take the third root, or the cube root of a to the 3rd times a, b to the 9th can just stay b to the 9th. And then 64, well, if I look at my perfect cube list, I have 1, 8, 27, and then 4 times itself 3 times. Well, guess what that makes? 64. So that's a perfect cube. So I don't really have to do much with that other than just kind of leave it there. If I take the perfect cubes, I'm going to get an a. I'm going to get a b to the 3rd power, all divided by 4. And the last one. So 16 becomes 8 and 2. X to the 7th becomes x to the 6th and x. Y to the 8th becomes y to the 6th and y squared. So then if we break down our cube roots, we have a 2, x to the 2nd power, y to the 2nd power, and I'm left with a 2, an x, and a y squared. And that's your homework and classwork from lesson number 5. Hopefully this video helped. Make sure you're checking these and preparing for your quiz next week.